Section 6.3, in this part of Section 6.3, we're going to divide polynomials using something called synthetic division. Now, in synthetic division, it's just sort of an alternative, shortcut little way that you can use to divide polynomials instead of long division. The only thing about synthetic division, though, that we can't do is we can only divide by linear factors. So unlike long division, we can divide with any type of factor, whether that's quadratic or cubic. But in this case, we're only going to be able to divide by linear factors. So in synthetic division, the idea here is that we get rid of all the variables and the exponents, and we work only with the coefficients of that problem. So like I mentioned, how important it is if you have any missing terms in that polynomial, you want to fill in your zeros as your placeholders. That's critically important when you're doing synthetic division because you don't have the variables to kind of indicate if there's a missing term or not. Okay, so we're going to look at a couple of examples of using synthetic division. I'm going to start with my first one here, and it's a little different how we set it up that we're doing synthetic division over regular long division. We're actually going to make a little box, but this time our little box is actually going to go the opposite kind of way that a division box would go. So we're going to make a box like this, and we're going to insert our part of our factor here, but we're going to use the opposite. Remember this A that we have here? We're going to take A and we're going to stick it right here in this box. And if you remember from our factor theorem, my factor is x minus A. So in this case, if my value here is a positive 1, and my box A is actually negative 1. So in this box, I'm going to put a negative 1. Then I'm going to list. Remember, we're taking out the variables, so we're just using the coefficients. And I'm going to list those coefficients right here next to my box. And as I go, I'm going to make sure that I don't have any missing terms here. So looks like I don't have any, so I'm just going to list my coefficients. So this is going to be 3, then a negative 4, then a positive 2, and a positive 9. Okay, so I had cubed, squared, x, and a constant. Okay. Then I'm going to leave some space, okay, right underneath here like this, and I'm going to draw my line. And so to start my synthetic division, I've got everything all set up now. I'm actually going to start it, and the first thing you're going to do is you're going to bring down your first term. So that is going to start with a 3. Then from here, the process involves this. Kind of like when we do our long division, right? You have to multiply. So we're going to take this number in our box, and we're going to multiply times this number down here under my line. So negative 1 times 3, and we're going to put that number right here under the next term. Okay, so negative 1 times 3 makes that a negative 3, and we're going to put that right here under my next term. Then we're going to add these terms together. So negative 4 and negative 3 make a negative 7. And I'm going to continue to repeat this process until I get to the very end. So this next time it's negative 1 times negative 7, which is a positive 7. Put that under my 2. And then 2 plus 7 is 9. And then I repeat again, negative 1 times 9 makes a negative 9, goes right there under my 9. And then negative 9 and negative 9 are 0. And when you do synthetic division, your last number here is your remainder. Okay, so I'm going to put that out here. This is remainder. Okay. And then, it's an A there. So that's my remainder. And then these numbers over here are my coefficients of my polynomial for my answer. So my actual answer, when I put all the variables back in, since this has 3 terms in it, right? This, and this will be my constant. This is a linear term, and this is a quadratic term. So my final answer is 3x squared minus 7x plus 9. And there was no remainder that divided evenly, so when I take 3x cubed minus 4x squared plus 2x plus 9, so this divided by x plus 1 is 3x squared minus 7x plus 9. And I can use that for several different things, for factoring, or if I wanted to know if it was an actual factor, I would say yes because I got a remainder of 0, all those things. All right, let's try the second example. So the second example, I have x to the fourth minus 2x squared plus 5x minus 10, and I'm dividing by x minus 2. So in my problem, I'm going to set this up, and my a value, this is x minus 2, so that makes a positive 2, so that goes here. And then I do my coefficients, right? So my coefficients here would be these numbers here. Start with x to the fourth, that coefficient is 1. Now this time I'm actually missing a term between x to the fourth and x squared. So I'm going to put a 0 for the x to the third, a negative 2 for the squared, a positive 5, and a negative 10. And then I'm going to draw my line, and I'm ready to start my calculations. So this time I will bring down the first number, which is a 1, do my multiplication. 2 times 1 is 1, so that goes underneath here. Do the addition, so that's another 1. Let's back up here. Maybe I should do my multiplication correctly. 2 times 1 is 2, sorry. Bring that down is 2. 2 times 2, whoops. So 2 times 2, right, is 4. We'll put that there. Negative 2 and 4 would be positive 2 again. Once again, 2 times 2 is another 4. And 5 and 4 make 9. 2 times 9 would be 18. Okay, and so negative 10 and 18 are 8. Now remember, your last term is your remainder, and these are my coefficients. So constant, linear, quadratic, cubic. So I'm going to have a cubic term left. That's going to leave me with x cubed plus 2x squared plus 2x plus 9 with a remainder of 8. Okay, so there is my division. So I would know that x minus 2 is not a factor of this particular polynomial. Okay, one last thing that we want to look at here, and that is called the remainder theorem. Now some of you, I know especially when we were doing long division, kind of thought, well, you know, I get these remainders and I'm not really sure if that's what I'm supposed to have or not supposed to have. So there's a remainder theorem that we can use, and we can actually check to see what we should be getting as a remainder, and then that can help us decide whether we did our division correctly or whether we did not. The theorem itself says that if you have a polynomial that's divided by x minus a, and a is a constant, then the remainder is you evaluate or calculate the value of the polynomial when you put a into the polynomial. So if I calculate, for example, the polynomial p of x equals x to the fourth minus 5x squared plus 4x plus 12, and I want to know what remainder I would get if I divide by the polynomial x plus 4, I need to take the a, and we've been working with that a lot, and plug it into this polynomial and calculate my answer. Okay, so first thing you have to know, though, is how do I get a? A, remember, is not a positive 4, right? My factor would have to say x minus 4 if a was positive 4. So again, it's that whole opposite thing. A is opposite of what you see in your factor. So since this is a positive 4, my a is a negative 4. So I'm going to take this polynomial, and I'm actually going to calculate p of negative 4. Okay, so when I do that, that's going to read like this. Negative 4 to the fourth plus 5 times negative 4 squared plus 4 times negative 4 plus 12. And I'm actually going to calculate that out with my calculator. So let's do that real quick. Negative 4 to the 4th power plus 5 times negative 4 squared plus 4 times negative 4 plus 12. And I get 172. Okay, so what this tells me is that I'm going to get a remainder of 172 if I divide the polynomial by the factor x plus 4. So very helpful when you're trying to decide if you actually got the right remainder or not when you do your division, whether that's synthetic or long division.